Hello friends, this is lecture number 4 of Fourier series, and here we're going to solve this problem. And in the next video we're going to discuss about half range series. Let me first solve this problem, okay? And links of previous lectures given in the description box. And before we start, please subscribe the channel if you are new to my channel, and also share with your friends and hit the thumbs up button if you like my videos. Also hit the bell icon so that you get notified when new video will be uploaded, okay? And please help me to grow my channel and inspire me to create new contents for you, okay? So now let's start. Here is the question: obtain the Fourier series for this function x sine x in the interval x greater than 0 less than 2 pi. Okay, so here is the given function, and let me consider that this is be the series. Let me write here. So now let us consider here, you see this. So I have considered f of x, that is the x sine x is equal to this is the Fourier series I have considered, and this is suppose equation number 1. Then let us find a naught first. So how to find a naught? 1 by pi 0 to 2 pi f of x dx. Now let's find how to find this f of a naught. Let me show you. So here 1 by pi integration 0 to 2 pi f of x is here x sine x, right? X sine x dx. If you integrate this, then what are you gonna get? So if you integrate this x sine x, considering this as a first function, this one as a second function, if you use a product rule, okay, if you use the product rule, what are you gonna get? Let me show you. So 1 by pi. So here we have used the product rule. This is u, this is v, u into v, and derivative of u into v is nothing but u derivative of we are integrating, we have used the product rule. If you have integration u v, right, u v, then u integration v minus integration derivative of u integration v dx, then whole dx. So we have used this property, okay? So this is the u, and this is sine x is the v here, and here again derivative of x, then this is integration of sine x dx, right? So hope you have understood this. So now, so what we have got here, 1 by pi and x minus x cos x, because you see integration of sine x dx, that's going to be minus cos x, then minus, and derivative of x is 1, so that's why we have got here 1, and integration of sine x dx, that's going to be minus cos x. Again we have integration here. If you again integrate it, then you will get minus sine x, right? So minus sine x into 1 remains minus sine x, and minus, and here this minus, that's going to be plus sine x, right? So that's what we have got, integrating from 0 to 2 pi, 0 to 2 pi, that's what we have got. So hope you have understood this. Now let me clear these things, okay? So now you see what will be the next step, and for 2 pi sine x, that's going to be 0, right? So if you put sine 0 sine 2 pi, okay, because sine n pi that is equal to 0, right? So that's why we have to deal with only this term, right? So the term containing sine gonna be vanished, right? So now let's put the upper limit and lower limit. So 1 by pi, if you put twice pi here, then what you will get, cos twice pi, that's going to be equal to plus 1, because it's going to be equal to minus 1 whole to the power 2, that is 1, right? Because we know cos n pi is nothing but minus 1 whole to the power n, right? So that's what we're going to get, right? So here let me cut this with, okay, this is going to give you, so first we have put minus 2 pi, then cos 2 pi is simply 1, so it remains minus 2 pi, then if you put 0, cos 0 is 1, and but 0 into x, this x also should be also replaced by 0, so 0 into anything is 0, so that's why we're gonna get only this 2 pi only, right? 2 pi. So here this pi cancels, so the result is minus 2. So what we have got? We have got minus 2 only. So this is the value of a naught. So we have got a naught is equal to minus 2, right? So we have got a naught is equal to minus 2. This is nothing but a naught, right? So this is our a naught. So hope you have understood this. A naught is equal to minus 2. Now let us find an. Okay, an. So here f of x is this function x sin x. So let us put that 1 by pi integration from 0 to 2 pi, from 0 to 2 pi x sin x cos nx dx, right? So let me go to the next slide. Let me copy this first. So this is what we have got. Now what we're gonna do is just first of all, what we can do here, here you see 1 by pi, so half into half. Then what you can do, you can just write x 2 into sine x, or you can write sine, first you can write cos nx. Let me write the cos nx first, then sine x dx. That's what you can do, right? So hope you have understood this. This is integration from 0 to 2 pi. So what we have done, we have multiplied by 2 and divided by 2, right? So that's what we have done. And here we're going to apply this identity that 2 cos a sine b, that is equal to sine a plus b minus sine a minus b. We're going to use that sine a minus b. Okay, so if you use that formula, so here you see this is cos a sine b, then what you're going to get, let me write here, just wait. So let me bring it here. So then you're going to get that 1 by 2 pi integration from 0 to 2 pi, 0 to 2 pi, then x sine a plus b. Here a is nx and b is x, right? So we're gonna get n plus 1 into x. That means x is taken common, right? So we're supposed to get nx plus x, that x is taken common, right? So hope you have understood this. Then minus sine a minus b, that is sine n minus 1 into x. That's what we're gonna get now, dx, right? So here you can see, let me evaluate this integration separately first, 0 to 2 pi. So let me evaluate this first. So x, let me copy these things, just wait. So that is what we have got. So again, use the product rule here. Use this product rule, integration u v dx, that's going to be equal to u integration of v dx minus integration derivative of u integration v dx, then whole dx. So let us use that one. So if we use that one, then what going to be our result? Let me show you. So here you see we have applied here product rule. This is u and this part is we have considered as v, right? So then this is the u, then integration of v, then derivative of u, that is here u is x, derivative of x is 1, then again integration of v, right? So hope you have understood this step. Now what we can do here, you can see. So integration of sine n plus 1 x, that's going to be, so let me write here, minus cos n plus 1 into x by n plus 1, right? Then minus integration of sine n minus 1 into x, that's going to be minus cos, so that's going to be plus, minus minus plus, cos n minus 1 x by n minus 1, that's what we're going to get, right? So because integration of sine, that's going to be minus cos, right? This minus, that's going to be plus, right? So hope, that's why we have got here plus. So hope you have understood this. So now minus, let me work on this part. So if you integrate this first, then you're gonna get this result. Then again, if you integrate that because of this integral again, then what you're gonna get? Okay, so if you integrate it once, you're gonna get minus cos n plus 1 into x by n plus 1, right? And if you integrate it again, so there are two integral sign, right? If you have to integrate it twice, once you have got this, and again if you integrate this, then again you will get minus sine n plus 1 x by here n plus 1 whole square. That's what you're gonna get. So in this term, in the next term, you're gonna get this minus will be plus, right? On integrating once, then here you're gonna get cos n minus 1 by n minus 1 whole square, right? Sorry, sine, you should get sine. Let me show you how. So here you can see, if you integrate this part first, then you should get this minus, there is minus, and if you integrate sine, then you should get minus cos, so that's going to be plus cos n minus 1 x by n minus 1, right? And there is another integration symbol, so if you integrate this one again, then you should get sine n minus 1 into x by n minus 1 whole square, right? So that's what you're going to get, and from this term you will get this, and from this term you should get this, right? So our result will be, let me write the result. So this is what we have got. Now you can see, if you remove this bracket, then what you're gonna get? So then this minus will be plus and this plus will be minus, right? So that's what we're gonna get. So a final result will be like this. So this gotta be plus and this should be minus, right? So hope you have understood this. So now let us use this result here. Okay, so here I have ignored the limits, just I have find the integral, right? So now use this integral here to get the result, then what you will get. So let me go to the next slide first. Okay, so we will get an is equal to 1 by twice pi, 1 by twice pi, and here let me use the bracket. So what was the result we have got? This is the result of the integral. So let me copy this result. Okay, just wait. So here let me copy this one. So we're gonna use this result here. So this is what we have got, right? So now what were the limits? 0 to 2 pi, right? So here you see, on putting 2 pi, those terms containing sine will be 0. This will be 0 because I have already mentioned that sine n pi, that is equal to 0. So this part will be 0. Okay, and sine 0 is 0 as well, so that's why we're gonna deal with this term only, right? So here you can see that if you put twice pi first, twice pi, and this x will be twice pi, and on putting 0, this term will be also 0 because there is x. If you put x is equal to 0, 0 into anything is 0, so that's why if you put twice pi only, you will get 2 pi then minus cos of n plus 1 into 2 pi by n plus 1, then plus cos n minus 1 2 pi by n minus 1. That's what we're gonna get, right? So hope you have understood this. So now you see this 2 pi cancels, and 2 into n plus 1, this must be even. If it is even, then cos of n plus 1 2 pi, that must be plus 1, right? So in that case, so our results is 1 by that is minus, so that's why I'm getting here minus n plus 1, then plus 1 by n minus 1. This is the result we're gonna get. This is an, right? This is an. So here you see one more important thing, that n cannot be equal to 1, because if n is 1, then this not going to be defined, so this term will be undefined. So n is not equal to 1. For n is not equal to 1, we have got this value of an. Then what if what will be the value of an for n equal to 1? That means what will be a1? Let me find that one also, because we're going to need this one also in this series, in the Fourier series, right? Because here you see, if you go back to the series, here we have an cos nx. There is summation from 1 to infinity, so that's why we must know a1. So let me find that one. Sorry, how to find the a1? So in order to find a1, we're gonna start with this expression first. From this expression again, so that is what f of x is x sine x, so cos nx dx. We're gonna use this result again. So now here you see, so this is the new slide here. Let me paste the result here. So if an is equal to this one, what will be a1? So a1 will be, so our a1, that's going to be given by 1 by pi 0 to 2 pi x sine x, and this n will be 1, right, in this case. So sine, sorry, not sine, cos x, we're going to get cos x dx, right? That's what we have got. So again, if you make it 1 by twice pi, then 0 to 2 pi x, then twice sine x, you can write twice sine x cos x dx, right? And you know that 2 sine x cos x is sine twice x, right? That is sine twice x. So using that result, what you will get, so 1 by twice pi integration 0 to pi x sine twice x dx. Now again use the product rule here, then 1 by 2 pi x integration of sine twice x, that's going to be minus cos twice x by 2. So let me find the integral directly. Okay, so minus again integration derivative of first function, that is x, that's going to be 1, then integration of the second function, integration of sine twice x, that's going to be minus cos twice x by 2 dx, right? So this is what we're going to get. So we are integrating from 0 to 2 pi, then again integrate it, you have to integrate this term again. So then what you will get, this is a1, right? So 1 by twice pi x minus cos twice x by 2, and then this minus, that's going to be plus, right? Plus again integrating cos twice x, you should get sine twice x by 2, and there is already one more 2, the 2 to the 4, that's going to be sine twice x by 4. That is what we have got, 0 to 2 pi. Again you see, we know sine n pi is 0, that's why this on putting the upper limit and lower limit, in both cases this term will be 0, right? So that's why you're going to deal with only this term. So if you put 2 pi here, if you put 0, then this x will be 0, 0 into anything is 0, so that's why let's put 2 pi only. So then what you will get, if you put 2 pi, and so 1 by 2 pi, we're gonna get values of for only 2 pi, right? If you put 0, you will get 0, so 2 pi that minus cos, if you put this x, replace this x by 2 pi, then it will be cos 4 pi by 2. That's what you will get, right? So let me close the bracket. So here this 2 pi cancels, and cos n pi is minus 1 to the power n, but here n is even, that is 4 here, so that's going to be plus 1. So that's why what will be our result, that will be minus half, right? So because there is minus sign, so it's going to be equal to minus half, right? So this is minus half. So hope you have understood this. So we have got a1 is equal to minus half. So now let me copy these results. What is the an here? We have got an for n not equal to 1. So this is the an. So let me go to the next slide. So this is what we have got. This is an for n not equal to 1. And what will be the value of an for n equal to 1? This is a1, right? So let me write that result as well. So this is the result we have got. And wait, so now let us find bn. Okay, so this is a1, right? This is a1. So just wait. So this is a1. Let me write it properly. This is a1. So this is the result of a1. Now let's find bn. 1 by pi integration from 0 to 2 pi, 0 to 2 pi. Then our f of x is x sine x. Then here again we have to put sine nx dx, right? Because what was the formula? Bn is equal to integration from 0 to 2 pi f of x sine nx, right? That was the formula, right? So here f of x is nothing but x sine x, right? So hope you have understood this. Now let's find bn. How to find that? So again, what we can do here, we have to multiply this one by 2 and divide it by 2. Okay, so that's what we have done. So then doing so, what we will get, let me copy these things. So we will get twice pi 0 to 2 pi x 2 sine nx, right? 2 sine nx. Let me write the nx first, then sine x dx. That's what we will get, right? So now using the product rule, this taking this one as u, this one as b, again integrate it, then what you will get. Let me go to the next slide first. Okay, first let me find the integral part first. Integration x 2 sine x sine nx sine x dx, right? Let me integrate this first using the product rule. If you use that product rule, then what you will get, x integration of 2 sine x nx cos x. Here we're going to use the trigonometric identity, and that is cos a minus b minus cos a plus b. That is equal to 2 sine a sine b. So here a is nx and b is x. Okay, b is x. So if you use this identity, then what you will get, then what you just let me use the identity before integrating. So integration, so then you will get x, and here applying this identity, you will get cos n minus 1 into x minus cos n plus 1 into x dx. That is what you will get. Okay, so now let us use the product rule now. Okay, taking this one as u and this one as v. Okay, use this rule. I have already said many times. Okay, u v integration of v dx, that's gonna be in u integration of v dx minus integration derivative of u integration v dx whole dx, right? So let us use this property. Okay, use this rule. So then what you will get, so applying the product rule, we will get this result. Then if you integrate this, I don't think I need to explain each and every step, because I have already explained many times how to integrate this kind of things. So let me rewrite the result now step by step. So this is our next step. Then integrate this part, then what you will get, let me show you. Let me go to the next let me do it here. So just simply you will get let me write the result directly. So this is the result we have got after integration. So this is the result of this part only, integration, this part, ignoring the upper and lower limits. So let me use this result here. So we're gonna put limits here, 0 to 2 pi, okay, to get Vn. So let me go to the next slide. Okay, just wait. So finally we have got this result, 0 to 2 pi. So what we have done, that we have used this result here. Okay, so this is the Bn we have got. So now here you see, if you simplify this, so 4 twice pi and 0, those terms containing sign, those gonna be 0, right? So why 0 I have already explained many times. Okay, so now let us deal with this part only, right? So then what you will get, then you see this 1 by 2 pi, for 2 pi, if you put 2 pi here, that's going to be 1, because cos n x n pi, that is minus 1 to the power n. If n is even, if you put here 2 pi, 2 into n or 2 into n minus 1, whatever, 2 into n plus 1, 2 into anything is always even. So that's why it's gonna give you plus 1, right? So here we will get 1 by n minus 1, sorry, that should be n minus 1 whole square minus 1 by n plus 1 whole square, right? Then minus, if you put 0, cos 0 is also 1, so 1 by n minus 1 whole square, then minus minus, that's going to be plus, because the result that putting the lower limit should be subtracted, that's why this minus sign comes, and because of this minus will be plus, right? So hope you have understood this, n plus 1 whole square, right? So we have got this part putting twice pi, and we have got this part putting 0, right? X is equal to 0. So that's what we have got. So here also this is not valid for n is equal to 1, so we have to find the bn separately, b1 separately. Okay, first this is the result we have got, and what are the terms that's going to be cancel each other. So let me find that one first. Here you can see that so this gone, these two also gone, right? So we have got bn is equal to 0. So what we have got, bn is equal to 0. So now let's find b1. Okay, so in order to find b1, we have to start it with this formula, bn is equal to 1 by 2 pi 0 to 2 pi. You have to integrate f of x f of x sine nx dx, right? So here for 1, this n will be equal to 1, right? So b1 is equal to, then we will get 1 by pi integration 0 to 2 pi, and f of x is nothing but x sine x, and then instead of sine nx you should write sine x dx, right? So hope you have understood this now. Okay, just got it. So now let me go to the next slide. Before going to next slide, here you see we will get 1 by pi 0 to 2 pi x, here sine x we're gonna get sine square x dx, right? So hope you have understood. Now let me go to the next slide. Let me copy this step first. So what we have got, so just wait. So now here you can see that just wait, 1 by pi integration 0 to 2 pi sine square x, you can write it as 1 minus cos twice x by 2. So you must know all the trigonometric identities, okay? Then only you can solve these kind of problems. So hope you have understood this. So we're gonna use this result, okay, instead of sine square x. So if you do so, then what you will get, then you will get here x 1 minus cos twice x by 2 dx, right? That's what you're going to get. So again, use the product rule here. Now here you see this 2 is taken out of the integral because it is constant. So we're going to get 1 by twice pi integration. If you multiply this x with this, then what you will get, x minus x cos twice x, right, dx. That's what you will get. Then 1 by twice pi, so integration of x dx minus integration of x cos twice x dx. That's what you will get, right? So now you see 1 by twice pi, if you integrate x dx, so here let me put the limits 0 to 2 pi. So here 0 to 2 pi. If you integrate x dx, then you should get x squared by 2, right, minus, and use the product rule here. First function, that is x here, integration of second function, that is cos twice x, then dx, minus this minus, because of this minus, that's going to be plus, right? Then integration of the derivative of the first function, that is 1, so derivative of x is 1 simply. So then again integration of cos twice x dx, right? So just wait, dx, then 0 to 2 pi. So then 1 by 2 pi x squared by 2 minus integration of cos twice x, that's going to be sine twice x by 2, right? Sine twice x by 2 plus, and again integration of cos is sine, integration of sine is minus cos, so that's going to be, that's why this symbol going to be minus. So minus, if you integrate it once, then you should get sine twice x by 2. And if you integrate this again, because of this integral, there are two integrals, so that's why you should get cos twice x by 4. That's what you will get, right? So 0 to 2 pi. So when you put 0 and 2 pi, x is equal to 0 and 2 pi, those terms containing sine, that's going to be equal to 0, right? Because sine n pi and sine 0 both equal to 0. So now this is what, this is b1. So let me go to the next slide first. Okay, this is the last step we have got in the previous slide. So here you can see for 2 pi and 0, in both cases this term will be 0, term containing sine x, that's going to be 0. So here we're going to deal with only these two terms, right? So if you put 2 pi, then you will get 4 pi square by 2, then minus cos 4 pi by 4, right? Then minus, putting the lower limit, you have to subtract the results. So minus, if you put 0 here, that's going to be 0. Then because of this minus will be plus, right? Minus, so we're supposed to get like this, right? Minus 0, that minus cos 0 by 4. So this minus will be plus because of this minus, right? So simply we can write 0 plus cos 0 by 4, right? So here you see 2 pi, so this 2 cancels, so that's why twice pi square, and this is cos 4 pi, that will be 1, then plus cos 0 is also 1, so here we have got 1 by, here also we have got 1 by 4. So now this cancels, so 1 by 2 pi into 2 pi square, 2 pi square. If you cancel these two, then you will get only pi, right? So this is the value of b1. So let me write all the values that we have got till now. So we have got we have got an. What was the value of an? So an is nothing but it is equal to this, right? So this was the value of an that we had got, right? Here, let me clean these things. Wait. So this is the value of n we have got, and if you take LCM and simplify, then what you will get? You will get n plus minus n plus 1, then plus n plus 1 by n square minus 1 square, that is 1, right? So here minus n plus n gone, so we have got minus 2, sorry, not minus 2, only 2 by n square minus 1. That's what we will get, right? So hope you have understood this. Now what was the value of bn? We have got bn is equal to 0. Bn is equal to 0. And what was the value of b1? We had got, so this is b1, that is pi. So b1 is equal to pi. b1 is equal to pi. What was the value of a1? So let me write this too here. So what was the value of a1? Let me write that one as well. So a1, let me go to previous slides. Okay, so this is the value of a1, that is minus half. So we have got a1 is equal to minus half. Okay, so let us use these values in equation number 1. What was the equation number 1? Let me go back to the first slide. So here you see, and this is the equation number 1. So let me copy this equation number 1. So last slide is this. Okay, so here is the equation number 1, right? This is the equation number 1. Now let me use all those values of an, a1, bn, b1 in equation number 1, right? So what we're gonna do, just let me write the equation somewhere. Let me keep it here. Okay, just keep it here. Okay, so what we're gonna do, using the values of, and I forgot one more thing, that is a naught. A naught is equal to what we had got. A naught we had got minus 2, right? This is a naught, so we have to use this value as well. A naught, right? A naught is equal to this one. Putting the values of a naught, a1, an, b naught, sorry, not b naught, bn, then b1 in equation number 1, in this first equation, in equation number 1. So doing so, what we will get, so here you see, so here you can see that x sine x. So if we use those results in this equation number 1, so a naught is minus 2. If you put here minus 2, that's going to be minus 1, right? So minus 2 divided by 2, that's going to be minus 1, right? So hope you have understood this. Now if you put a naught, a1, so because this series starts from 1 to infinity, so for a1 we have got minus half. So that's why here we're going to write minus half cos nx. So instead of n, there will be 1, because we are doing it for a is equal to a1, so n is equal to 1 here, cos x. Then if you put the value of an, and this is for not equal to 1, that means we have to start from 2. Okay, from 2, then here you will get plus 2 by 2 square minus 1 cos twice x. Now n is equal to 2. Then similarly 2 by 3 square minus 1 cos thrice x. Then plus 2 by 4 square minus 1 cos 4x, right? And so on. That's how we're gonna continue, right? Then plus the next series. So here bn is equal to 0 for n is not equal to 1, right? But b1 is equal to pi, so here we will get only one term, that is for b1 is pi. So if you put here pi, then you gotta get pi sine x. That is what you will get, right? So now you see, from all those terms, from here, if you take 2 common, then our final result will be something like this. Minus, let me write this one first, in the second term. So here plus 2 pi sine x, then minus half cos x, then the remaining terms, that is 2 is taken common. Let me start it from here. So here x sine x, right? So let me write it properly. X sine x, just wait. So this is what x sine x, that will be equal to, on taking 2 common, from here you will get 1 by 2 square minus 1 cos x plus 1 by 3 square minus 1 cos that should be twice x, right? Here twice x, and 1 by 4 square minus 1 cos 4x, and plus so on. That's how it will be continued, right? So hope you have understood. This is our required result. Okay, so hope you have understood all these things, and please stay connected and motivate me to create new contents for you. Subscribe the channel, share with your friends, hit the thumbs up button, hit the bell icon so that you get notified when new video will be uploaded. Okay, so see you in the next video. Thank you for watching. Bye.